200 grams of water at 0 degrees Celsius is brought into contact with a heat reservoir at 80 degrees Celsius. After thermal equilibrium is reached, what is the temperature of the water of the reservoir? Of course, the water comes to 80 degrees, and the reservoir, by definition, its temperature does not change. It's a heat reservoir, meaning it's able to supply an unlimited supply of heat in principle. Okay. How much heat has been transferred in the process? Okay, so water gains heat. The amount of heat gained by water is mass of water, specific heat of water times its change in temperature. 200 grams, which is okay, we'll calculate in joules. So the mass of water is 0.2 kgs, and specific heat of water 4186 joules per kg per degree Celsius or Kelvin. Change in temperature of water is 80 degrees, 80 minus 0 degrees Celsius. So the heat absorbed by water is 6.74 into 10 to the power 4 joules. And what is the change in entropy of the water? So change in entropy of the water, for water, the small change in entropy when it absorbs this much amount of heat is that mc dt by t, and delta S is integral of ds mc dt by t, t initial to t final, mc log t final over t initial. All right. So for the water, the change in entropy is mc log of T final minus T initial, which is 0.2 kg for 4186 joules per mole per Kelvin, log 80 degrees is 353 Kelvin divided by 273 Kelvin. So that is equal to 215 joules per Kelvin. That's for the water. Okay, what's the entropy of the reservoir? So for the reservoir, the water gained this much heat. So the change in entropy of the reservoir is amount of heat gained or lost or divided by temperature. And the reservoir loses this much heat, 6.74. So minus 6.74 into 10 to the power 4 joules, and it loses it at a temperature of 80 degrees Celsius, which is 353 Kelvin. And this should equal minus 191 joules per Kelvin. And the entropy change of the universe, of course, should be, this was a naturally occurring process, so should be greater than 0. Water is delayed. 215 minus 191 joules per Kelvin. That's 1524 joules per Kelvin. Okay, so again, the change in entropy of the universe is positive.